Alright, this is a lesson about angles in standard position. By the end of this lesson, you want to be able to understand what standard position is and how we can use standard position to find rotations of an angle. Turn the page. This is meant for terminology. When you're doing the investigation in the following pages, I want you to use the terms initial arm, angle, and terminal arm. In all cases, the angle will be going counterclockwise from an initial arm. That'll be done to try and keep things simple. You need to use the terms initial arm and terminal arm to try and help you describe things in the investigation. Turn the page. Start here. You need to go through part A and B, 1 through 5. Complete those, pause the video, spend the next 5 minutes or so going through all of that. So pause it now. Alright, now you've unpaused it. Collecting what you've done, part 1 here, group A, these are all angles in standard position. Here we can see for all of these, they have an initial arm along the x-axis. They have their terminal arm some angle away, where the angle is taken counterclockwise from that initial arm. The initial arm always along the x-axis. The vertex of the angle is always right at the origin, right where the x and y axis cross. We can see that this is true for an acute angle here, an obtuse angle here, or a reflex angle here. Group B, all these angles do not follow that pattern. Here we can see the vertex is not at the origin. Yes, this initial arm is parallel with the x-axis, but it's not actually over here where it should be. This angle has an initial arm that doesn't start where it should. The initial arm should start here, and the angle should go up to some point. Here we have multiple things wrong in the last example. With number 2, which one shows the angle of 70 degrees in standard position? That has to be B. You might be tempted to say C as well, however that's not the case. This is going to relate into other terms we use with angles. When we use angles in standard position, it always has the vertex at the origin, the initial arm to the right and along the x-axis. The angle is taken counterclockwise from that. In C, this is the initial arm here. The angle is then taken counterclockwise from that, so we really don't have the initial arm along the x-axis. Turning over. Part 3. All of these angles should be on some kind of grid. So you need to make some kind of grid. I'll make one here in blue. This will be for A. This will be for B. This will be for C, and this will be for D. I'll make the angle in green. For A, 75 degrees, that should always have an initial arm like this. 75 degrees is something less than 90. This is enough for that. I didn't need this done with a protractor, just something approximate to show that you understand what this pattern is. B over here is 105 degrees. We have our initial arm. 105 degrees is more than 90 degrees, so we should have some angle that looks approximately like that. C, we have 225 degrees. This is bigger than 180. Less than 270, so that will rotate all the way around to here somewhere with the terminal arm, something like that. And then the last one, D, we have the initial arm to the right. This is more than 270 degrees, so that will rotate all the way around past 270 degrees to over here somewhere, where the terminal arm is like that. This is a reflex angle. It's rotating more than 180 degrees. All right, going down to 4. We want to consider the angle that we've drawn. How might this define an angle in standard position? Key points. The initial arm is along the x-axis to the right. The vertex of the angle is at the origin. The terminal arm ends where the angle does. The terminal arm is always taken counterclockwise from the initial arm. Those things sort of defining standard position. Part 5, or question 5, we need to describe how we could draw these angles. Usually when we have a protractor, it only goes up to 180 degrees. So we're thinking of our protractor that looks like this, from 0 to 180, or maybe we have the semicircle kind from 0 to 180. Regardless, that makes it harder to make an angle of 290, for example. I'll focus on B, because I think that example might make the most sense. For 200 degrees, we could think of this in two ways. One way, which I'll do in yellow, one way is our protractor only goes up to 180, so we can draw an initial arm. We know that directly across is 180. So really, to make this angle of 200 degrees, we just need to draw 20 degrees more than that. So our angle of 200 degrees would be this. From the initial arm all the way counterclockwise this far. Here we've added 180 degrees and 20 degrees to get that 200 degrees. Alternatively, what we could have done to draw an angle like this is have our initial arm, and we know, annoying. Sorry, I clicked on something I shouldn't have. So, here we have our initial arm drawn to the right. We can notice that 200 degrees, if we were to think of this with this yellow diagram, we have 200 degrees, and for a full rotation, we know that's 360 degrees. We know that there is 160 degrees left. So one thing we could do is we could have our initial arm. We could measure back 160 degrees this way. And then because we've done that, this angle here must be 200 degrees. We've used the fact that we've gone clockwise 160 to make that 200 degrees. Okay, turn the page. We have this here. This is terminology about angles in standard position. We have our initial arm, the terminal arm. We have the angle in standard position. These are three bolded terms that we need to use to describe this angle. The newer part, though, I think the more important part for us, is about when it talks about quadrants. We have 4 quadrants on a Cartesian plane. A Cartesian plane, again, is just an x and y axis. So this is what we're looking at here in the right diagram. There are 4 corners in this graph. We have a top right corner, a top left corner, a bottom left corner, and a bottom right corner. And these all relate to some angles when we use angles in standard position. In quadrant 1, we have angles between 0 and 90. Quadrant 2, we have angles between 90 and 180. Quadrant 3, we have angles between 180 and 270. And quadrant 4, angles between 270 and 360. We need to know the names of these quadrants. We start with the top right corner as 1, the Roman numeral for 1. And then we just go counterclockwise, so 2, 3, and 4. We'll need to know that in different examples. So turn the page to reference angles. Reference angles are angles that we can use to help describe angles in standard position. They're always taken from the x-axis. So when we did question 5 in the investigation, we used a reference angle. If I turn the page back to here, we used a reference angle in this yellow example. here. We use the reference angle of 20 degrees below the x-axis on the left-hand side. So 20 degrees in, if I draw a coordinate system, in quadrant 3 means that we have the angle of 200 degrees. This 20 degrees is an example of a reference angle. 20 degrees isn't enough to define 200 degrees, but saying 200 or 20 degrees as a reference angle in quadrant 3 is enough. Here's our coordinate system, quadrant 1, 2, 3, and 4. If we're in quadrant 3, and we have to make our angle from the x-axis, then saying 20 degrees in quadrant 3 as our reference angle must mean this: 20 degrees down from the x-axis. This defines 200 degrees in standard position. So that's what it's talking about with reference angles. Turn back to that. Here it shows at the bottom of the page. We can see this is what it looks like if we're given a reference angle. A reference angle in quadrant 1 goes up from the x-axis. A reference angle in quadrant 2 goes up from the x-axis, but over here. A reference angle in quadrant 3 goes down from the x-axis here. And a reference angle in quadrant 4 goes down from this here. So we have in red, in all cases, our angle in standard position. In black here, our reference angle, some angle taken from an x-axis. We need those two terms. So we turn the page. We'll do an example together. Try your turn on your own. So we need to sketch an angle in standard position. State the quadrant in which the terminal arm lies. In all cases, draw, just even as a sketch, a set of axes. "36 degrees is between 0 and 90, so we'll have something like this, approximately. This is clearly in quadrant 1. 210 degrees, here's our initial arm. We're going around past 180 degrees to approximately here. This is ending in quadrant 3. 315 degrees, we have our initial arm here. We're going around 90, 180, 270, and a little bit more. There's our terminal arm in quadrant 4, 315 degrees. Try the next ones on your own. In fact, try and beat me doing those examples. Check your work. Example 2. We're talking about a reference angle now. So we want to determine the reference angle given with a theta, the Greek symbol for an angle, with a lower r, a subscript r, to let us know that it's a reference angle and not just the angle by itself. We want to sketch the angle in standard position and label the reference angle. So this is an example like was done in 1. Start with our axes. We have our angle of 130 degrees. It's going to bring us past 90, approximately up here. Our reference angle, in this case, is taken from the x-axis to the terminal arm. So here, in green, is our reference angle, theta r. We have 130 degrees going to here. The remaining amount must be 50 degrees because it adds to 180 degrees, a straight line going all the way across. Our angle 130 degrees, reference angle 150 degrees, ending in quadrant 2. Same idea for B. Make our axes. Our angle is 300 degrees, that's more than 270. So approximately here, 300 degrees. We're ending in quadrant 4. Our reference angle is taken from the x-axis, so it's this part here. And this is 300 degrees. It's 60 degrees less than a full rotation. So we have 60 degrees and 300 degrees making a full rotation, 360. Our reference angle, is 60 degrees. The piece that would have to be added to 300 here to make 360. Try the next two on your own. Try and beat me as I do that example. Check your work. In A, here we have the reference angle is the same as the angle. For B, we've taken 180 degrees from 240 degrees. 180 goes to here. We have a remaining 60 degrees left to reach that angle. The reference angle always taken from the x-axis. We have quadrant 1 in example A, quadrant 3 in B. One of the last examples here, we want to determine the angle in standard position when an angle of 40 degrees is reflected in the y-axis, the x-axis, and the x and y-axis. So start with the coordinate. Here we have our angle of 40 degrees. For A, it's reflected in the y-axis. In other words, in the y-axis. It doesn't say over the y-axis. It says in the y-axis, meaning in the y direction. So it's flipped vertically. To be honest, I don't like the wording of this. If I was to ask you a question on a test, I would say the angle of 40 degrees for A. I wouldn't have worded it like that. I would have said flipped over the x-axis. Meaning we use the x-axis like a mirror is how I would have worded that. Using the x-axis like a mirror gives us this 40 degrees as our reference angle. An angle of 40 degrees as our reference angle relates to an angle of 320 degrees from an initial position all the way around to there. So the angle in standard position, when the angle of 40 degrees is reflected in the y direction, flipped over the x-axis, is 320 degrees. So that's A. For B, I also don't like the wording of that. The way I would word B is 40 degrees is flipped over the y-axis. So see if you can beat me as I do this example. We have 40 degrees is drawn. We flip it over the y-axis. We treat the y-axis like a mirror. Our reference angle is over here. That means that our angle from the initial arm here up to this point must be 140 degrees, because 40 and 140 must add to 180, that straight line. For C, it's flipped over the y-axis and the x-axis, so it's made into this position and then flipped over the other axis. So it's in fact flipped over both axes. From here, we can see that this angle is going to be flipped into this position down here. It's been, from this point, it's been flipped to here, and then flipped to here. Using this reference angle, we should add that with the 180 degrees. There's our initial arm, here's our terminal arm. We have 180 plus 40, which is giving us 220 degrees for that angle. Try the your turn on your own. You should get the same sort of idea as we did in this example together. So for A, vertically flipped, but 60 degrees is vertically flipped, so it's down like this. That means our angle that we're talking about is 300 degrees. For B, it's horizontally flipped, so 60 degrees is here, flipped, brings it over here. This is giving us an angle in standard position of 120 degrees. And C, again, it's flipped over both axes, so it's flipped and then flipped. We have something like this. That angle in total being 180 plus 60, 240 degrees. Try the practice questions on your own. You should be able to complete all of these at this point. Questions 1, 2, 3, 4, 6, and so on.